Overcoming saber-toothed tigers and woolly mammoths, we must now face a new enemy, ourselves. With the rates of diseases such as heart disease, stroke, diabetes, depression, and many others ballooning, we must find a better solution to these modern epidemics. Welcome to the Preventive Medicine Podcast. We believe in building a foundation of health by means of prevention so that you can build the life you want and find fulfillment with no barriers. Hear from experts around the country on how to take your health into your hands. Take control and build a foundation of health for the life that you want to live. And now, here's your host, Raghav Sharma. We hope you enjoyed the show, and if you do, please don't hesitate to subscribe and like for all of our future content. Welcome back, everyone, to another episode, and today we're going to be talking about poop. Nope, not literal poop, but kind of the gut and gut health and everything that goes along with it. And you've already heard the intro. This is Dr. Gabrielle Fundaro. I'm extremely excited to talk about this because the gut is something that's actually been a personal interest of mine for a long time, despite me not going to GI, all those kinds of things. But welcome to the show.
Thank you for having me.
Definitely. So the first question is, you have a PhD in human nutrition, or kind of the gut expert, have written a book on it, but what does your day-to-day look like and what do you actually do?
Oh my gosh, I feel like I wear 1,000 different hats. So in addition to producing gut health related content for CISSN, I also contribute to Barbend. I run my own lifestyle coaching telehealth business, Vitamin PhD Nutrition. I am also currently running a year-long gut health webinar series where I'm bringing on experts and providing people with additional information on the actual science of the gut and gut microbiome. And I'm also putting together a series that will be available on a very, I guess I'll say, well-known website all about the gut and its relation to human health and disease. So day to day looks like, I have a pretty nice morning routine of like waking up naturally, taking my dog for a walk, taking care of my plants, stretching. And then it's a lot of writing and some, really amazing and fulfilling conversations with clients. And then I also collaborate with my good friend, Shannon Beer. We run the Comprehensive Coaching Facebook group. We put on webinars. We are curating, coach education on the comprehensive coaching framework that we've put together. So there's also, creating content for that group. And and so it's kind of like a lot of staring at a computer screen and using my brain. And then I get to go lift some heavy stuff at the end of the day and, interact with people on social media. So that's kind of my day to day.
I asked a lot of guests what they do on a day-to-day basis and what they do, and no one has actually given me a day-to-day. So I really appreciate that answer because everyone says, oh, I do this, but you took me through nice morning routine. You took me through the rest of your day. I really appreciate that. I just want to put that out there.
That's good. That's good.
And when I was doing my research for this, it sounds like you wear a million hats. Mm-hmm. And you've been doing a lot. You've been interested in fitness and nutrition for quite a bit. And I saw that you did your thesis in something related to the gut. But can you tell us a little bit about how you got interested into the gut?
Yeah, it's sort of it was a serendipitous journey because I actually started my doctorate attempting to study the effects of high fat feeding on skeletal muscle hypertrophy and looking at how that affects the mTOR pathway. And that was my primary project. And at the time, I was doing a lot of the animal husbandry work because I was like the person who would deal with the mice. I was okay with it. And I was doing a lot of intraperitoneal injections of something called lipopolysaccharide. And that's an endotoxin that can escape the intestinal tract and bind to immune receptors in the periphery. And I wanted to know why we were using this specific intervention. Like, what is this supposed to model? And that's when I learned that there are certain microbes in the gut that when they are destroyed, their cell walls can release this endotoxin. And so I wanted to get to, sort of the source of the potential issue and see if we could mitigate the metabolic effects, by changing the microbiome in some way. We really didn't have funding for that until I was about 6 months into my PhD, and then we received funding from a probiotic company.
Hmm.
And so my side project was the application of probiotics during high fat feeding to see if it would change some of the downstream metabolic effects. But through a series of unfortunate events that led to losing all of the tissues from my main project.
Oh no.
Yeah, just improper storage. We
I've
ended
been
up.
there, unfortunately, in
It's
undergrad. It's not.
Yeah,
It's not fun.
no, it was tragic. I can still remember like the complete meltdown that I had that day. Because also, that first project went off without a hitch. It was 6 months, no, we didn't lose any mice. The tissue collection was excellent up until, it wasn't stored properly. So it was really upsetting, but fortunately I had this side project, and so that became the main focus of my dissertation. We ran multiple cohorts of mice, and then I helped to develop the follow-up human study that I unfortunately didn't get to take part in, because by that time I was done with all my mouse research. I was about finished with my teaching fellowship, and I went off to teach, and I didn't have any plans to use my dissertation research in any way. It was sort of a means to an end because I really wanted to teach.
Hmm.
And so I went on to teach sport nutrition and exercise science, A&P1. A lot of the pre-nursing
Hmm.
majors, unfortunately, had to deal with me. And so I did that for 4 years. And in my fourth year, I was recruited by Renaissance Periodization to be a nutrition coach. So for a year, I did that part time while teaching full time. And then it came time for me to decide whether I was going to go up for a promotion or go the entrepreneurial route, because I found that to
Hmm.
be incredibly fulfilling. And so I resigned, and it was actually Mike Israel's idea for me to start speaking about gut health on podcasts, because back in 2017, there weren't as many evidence-based gut health
And there still
presences.
aren't.
Yeah, well, yeah.
That hasn't changed, unfortunately.
I know. I think the only thing that's changed is like the number of people who are talking about it. It's increased exponentially. And from there, I mean, it was a snowball effect. I did that first podcast with Steve Hall, Revive Stronger, and then it was another podcast request the next week. And I thought, oh my gosh, this is so cool. And then within a few months, it was multiple podcast requests in a week, and people were really hungry for more information about the gut. And then I ended up writing the gut health book. So I wrote that with my friend, only an IG friend. We've never met in person, but we wrote The Science of Gut Health, what the research really says about your gut microbiome, which is still available on the RP website.
And that's the book you're talking about with Dr. Jesse Hoffman, right? Who has
Yep,
been a
yep,
guest on our podcast as well. So if you're listening, let's go check that one
yes.
out as well. Great one.
Yeah. Yep. So she's fantastic. And so that's kind of where when I left Renaissance Periodization, Examine reached out. Just again, it was being in the right place at the right time, and having the availability to start writing gut health content for them. And so I am here doing that today.
Perfect. And here you are, 1,000 podcasts later. You're
Yeah.
definitely like the gut health expert. And like you're saying, you are still one of the only evidence-based people out there that is talking about gut health, which is why I want to talk to you, because the gut is something that when it comes to preventive medicine, which we'll get into in just a second, I know the listeners are waiting for preventive medicine, but when you talk about it, there's so much hype out there around like feeding your gut. It'll cure so many other problems. You'll practice so much prevention in so many different ways. And that's why I wanted you on here, because you are the person to talk about this. So let's get into it. And the first question is, what does preventive medicine mean to you?
Um, I was thinking about this, and I almost think it is not an oxymoron, but the two words don't necessarily fit together in my mind,
Hmm.
in terms of, medicine to me is sort of a reparative or curative type of thing. It's something we do to treat an illness,
Hmm.
whereas prevention is something that we do to hopefully stave off the development of illness. And so when I think about preventative medicine, I think that, it's perhaps a name that people apply to behaviors that would actually help them reduce their need for certain medicines, if that makes sense.
Definitely. I actually have not heard that before. Coming on this podcast, I hear various definitions of this, and no one kind of juxtaposes those words against each other. So that's interesting. It's a unique perspective. Definitely, I can see that. But let's start talking about the gut, because, like I was saying, people often link the gut to prevention, whether
Mhm.
it's health, style, whatever it is, lifestyle behaviors.
Yeah.
So they say the key to the entire health is our gut, and working on gut health has become preventive, with people prescribing probiotics, prebiotics, all these kinds of things. They say it can cure things like depression, diabetes, and whatnot. So when did the gut become linked with our health in such a large fashion? And is this actually the case?
Oh my gosh, probably about 2000 BC when Hippocrates stated that all disease begins in the gut. But back then they still thought that disease was caused by bad humors. So I think the idea that gut is a root cause of disease has been around for much longer than we probably give it credit for. But the evidence to support that is lacking. And only recently have we even been able to study the gut microbiome with enough depth and a high enough resolution to see what might be going on in there, and to start drawing some correlations between certain microbes and certain diseases. And certainly, we can do things to support our microbiome, which would also coincidentally support our health and prevent the development of disease. When we're thinking about something like following a dietary pattern that is rich in polyphenols, that provides a diversity of plant-based foods. That can be protective against cardiometabolic and disease and colorectal cancer. And it also does provide a wide variety of nutrients for those gut microbes. But when we try to establish a cause and effect relationship between the gut microbiome and disease or health, we really are stymied by both the abilities of the technology that we have today, and also the fact that the gut microbiome is an exceptionally complex system. And we may never actually get to a place where we can establish causality between the gut microbiome as a whole and health or disease, because it is almost impossible to fulfill the Koch's postulates, to establish causality.
Definitely. I want to take a step back here for those who might be living under a rock or whatnot that don't know what the gut microbiome is. First of all, what is it? And also, you mentioned that it's incredibly complex.
Mm-hmm.
Why is it so complex? Like, what's going on with these bacteria? They're very simple organisms, right? How did this become so complex?
Right, right. Yeah. And I think it's like, when we think about it being simple, that can be sort of subjective, because, we might think that like an ant is a simple organism, but it is still an extremely complex one. And the system in which it operates might operate sort of as one unit, but it still is a very complex unit. You can think of the microbiome like an ecosystem. It is the collection of microbes, so that includes bacteria, archaea, fungi, not yeast, viruses, and all of their genetic material existing within the environment of the intestinal tract. So that's the microbiome. Now, the number of genes that they have outnumber ours by perhaps magnitudes of 100 times, and there are tens of trillions of microbes living in our intestinal tract. And the anatomy and physiology of the intestinal tract influence what we call the biogeography of those microbes. So where microbes live, in the same way that there are certain creatures on the planet that thrive only in hot and dry environments, and others need it to be cold or need a lot of humidity. Microbes are very similar in that they occupy specific niches in our intestinal tract. When we say microbiota, we're only referring to the microbes themselves, but not the genetic material. But I generally use the term microbiome because when people are talking about gut health, they're really thinking about all of them together, like both the microbes and their functional capacity.
Cool. And then one other question, I guess, just a logistical thing for people who are thinking about kind of bacteria within our lining. Are those
Mm-hmm.
not wiped out when we poop? Because like when we eat food and whatnot, do they not just like slide out bacteria, all those kinds of things?
Well, actually, yeah, we do excrete quite a lot of bacteria in our fecal matter. So a large portion of our fecal mass is dead cells, including dead microbial cells. But that being said, there are microbes that like to hang out in the lumen of the intestine, so like the empty space, the tube, or like the inside of the hose, so to speak. And then there are microbes that attach themselves to the intestinal wall. So they want to be associated more with the mucus layer that covers the intestinal cells. And that's especially the case when we're looking at the large intestine, which is a very thick bilayer of mucus. So those mucus-associated microbes actually are underrepresented in stool samples for that reason. They really can hang on pretty well. And while you might excrete, a number of live microbes in your stool as well, it's not enough that you're going to, wipe them out completely.
Sure. And in the name of kind of bolstering some of these populations, I know a lot of people have kind of suggested taking prebiotics, probiotics, and a whole bunch of other variety of supplements. We have
Sure.
influencers online selling various teas, whatever else is out there in the name of supporting these microbiomes and microbiota and whatever terminology that they want to use because they don't really know what it is when they're prescribing these things. But kind of what are these things, and then what is it? What do they do, and when should they be consumed?
Mm-hmm. So a probiotic is a live microorganism that, when consumed in adequate amounts, confers some benefit to the host. That's the World Health Organization definition at the current moment, and it could change in the future because there is some evidence that microbes don't necessarily need to be alive to exert some effect. So they have to have some beneficial effect on the host in order to be considered probiotic. And they need to be consumed in adequate amounts, but we don't really have a cutoff of what that actually is. So that's, again, another limitation, in determining the efficacy of probiotics. The effects of probiotics are strain specific. So when we think about, organization, like taxonomic organization of microorganisms by their genetic relatedness, we can have a species of bacteria that includes a number of different strains or subspecies. And within one species, you can have strains that have wildly different effects. Like some could be pathogenic and some could be beneficial. And when we do have a beneficial strain, the evidence indicates at the moment that it's really going to be effective for probably just one or two things. Like it could be, diarrhea associated with antibiotics or IBS. And like this strain works just for that. It's not going to help you with, say, abdominal pain or constipation. And there's quite a lot of evidence to indicate that healthy individuals don't need to use probiotics. I mean, they don't have any sort of ill health that they're trying to address with the probiotics. And that also probiotics might just pass through. So they are ingested, they come out in the fecal matter, but they don't actually enrich the microbiome in terms of they don't, not sticking around long enough to do anything. And that's not a huge concern. It's not like entirely shocking to know that our microbiome isn't very easily influenced by something like a supplement. That's actually probably a benefit to us because that means that we have a high level of resiliency and redundancy built in so that we don't have an ecosystem that's going to like crumble because it's been challenged by, a foreign microbe or antibiotics.
Definitely. I think that resiliency is probably huge because
Yes.
the amount of stuff that we put in our body sometimes just, you can imagine the harm that it's doing, but the microbiome is resilient.
Mm-hmm.
You mentioned IBS and other abdominal kind of diseases. In the hospital, we see lots of patients, unfortunately, with like C. diff, Clostridium
Yes.
difficile, and all those kinds of infections.
Yeah.
So how do you know what to replace when it comes to those kinds of diseases? Are probiotics beneficial in that instance where you just kind of bolus them with a bunch of kind of new bacteria?
That's a good question that really hasn't been answered yet.
Huh.
Now, in the case of C. diff, fecal microbiota transplant is an extremely effective intervention in cases that don't respond to antibiotic treatment. So if you have a really resistant form of C. diff, and you've gone through rounds of antibiotics, vancomycin, and it's still not working, then doing a fecal microbiota transplant can effectively cure the C. diff infection. And that's done by transferring a fecal sample so that can be encapsulated. It's ingested orally, or it can be delivered via after like a colonoscopy prep in sort of like an enema form. You're taking fecal matter from a healthy individual and you are providing it to a person who has C. diff. And then they are essentially repopulated. I mean, not entirely, because you can't completely wipe out their microbiome. But that seems to be the most effective application for fecal microbiota transplants.
One question. Oh, sorry. Were you continuing? Go ahead.
Oh, yeah. I was just going to say now, in terms of using probiotics to recover the microbiome, after a challenge, there's not a lot of evidence on that. It's very difficult to design those studies because, you have to get a group of people, basically like, wipe them out with antibiotics or something, and then you give them some variety of probiotic strains. But here's the issue. If you give them just one, okay, you can determine maybe if that one strain is effective. But now have you put them in harm's way by giving them, huge amounts of antibiotics and then replenishing them with just one strain? And there is evidence from at least one study that I know of that actually that did delay reestablishment of their microbiome, that there was an overgrowth of the probiotic strain, perhaps at the expense of other strains. But if you give them a whole combination probiotic, like throw everything, in the kitchen sink, you can't really determine then which of those strains was effective for promoting that reestablishment. And that, again, what looks to be most effective is actually doing an autologous fecal transplant. So a person uses their own fecal sample from before, they did the challenge of, antibiotics, that brings them back to baseline more quickly. Now, on the other hand, we have to consider whether it is really a problem to have a new set of microbes after a challenge. Like, just because you aren't where you were at baseline, does that necessarily mean that you have dysbiosis? Like, is it really an issue? Or do you just now have a new set of microbes that still maintain the amount of functionality that you had before? And that's a question that we just haven't answered yet.
Sure. And I want to ask a follow-up question, kind of the repopulation. If you're doing a fecal transplant, this is the stuff of legends. I haven't seen it in the hospital yet. Most patients just get a lot of antibiotics, and then it's kind of an outpatient thing, which we don't really see in the hospital. I'm assuming it's an outpatient thing. But the question that I have is that some people say, well, I'm not as well read in this literature, unfortunately, but some people say like your microbiome is kind of very individual to you, and it's kind of somewhat of a footprint of your own system. So if you were getting a fecal transplant, let's say it's not autologous, it's not from yourself, how does that impact the rest of your health when you kind of have someone else's population, their own footprint in your gut? Do we have answers to that yet?
Some. We don't have very strong evidence, and we don't have interventions that have been replicated. But we have used fecal transplants in hopes of trying to recapitulate like rodent data. So we've done fecal transplants in rodents that have transferred a phenotype from one rodent to another. Now that could be overweight, or obesity, feeding behaviors, anxiety-like behaviors. That when they do a transplant from one rodent to another, that it is almost improbably successful. So there's a high likelihood that in these rodent studies, there is some form of bias. Now that could be, researcher bias that they're saying, oh yes, that's definitely an anxiety-like behavior. Or it could be a statistical bias. So they're doing a pseudo replication where one rodent might get, or multiple rodents might get a transfer of fecal matter from just one donor, usually going to be a human. And if they don't adjust their statistics properly to say like, this is just replications of one sample, then that can inflate the data. So there are those limitations to keep in mind when we're looking at like how much a microbiome transfer can then transfer the behaviors or the health of the donor. In humans, there have been some cases where a fecal transplant has exacerbated inflammatory bowel disease. And so, we could say like perhaps that's some evidence to indicate that the fecal transplant actually played some role in the pathogenesis of the disease. They've also done at least one intervention with fecal transplants from a lean donor to a donor with obesity, and they didn't see any effects. There was no improvement in metabolic health. So it's really inconsistent in terms of the ability to translate both like from rodents to humans and also like translate from disease to disease, where we have extremely high level of efficacy in C. diff, but then nothing happens when we're looking at metabolic disease.
We want to take a quick break to remind you that this podcast is not intended for medical advice and is for educational and informational purposes only. We also want to remind you of our Instagram page at PreventPod, where we share various content relating to each episode that you can share with your friends if you enjoy our episode. And lastly, don't forget to sign up for our mailing list so you know right away when an episode goes up at www.thepreventivemedicinepodcast.com. And with that, let's get back into this episode. Anyway, so most people don't talk about poop this much, and most people are not getting fecal transplants. Like this is not a commonplace thing by any means, and most people will instead be ingesting food. And I know previously we mentioned how our gut is really resilient, and thank God it is, because we put some Taco Bell in there and some other fast foods, and it does really well with them for the most part. But do certain foods, quote unquote, ruin the gut microbiome, as some might say online?
Well, if you eat a food that like it contains listeria or E. coli, that produces Shiga toxin, then you could say that you're going to be pretty ruined after that because you have ingested a microbe that causes foodborne illness, and you probably will have, extreme diarrhea and vomiting. And, there is some evidence, actually, interestingly, looking at people who've had COVID, that there are some long-term changes to the microbiome post-COVID. Do we know that that's ruined? No. And I think that's one thing that I should probably caveat this by saying we don't have a consensus definition of a healthy gut microbiome, nor do we have a consensus definition of dysbiosis, which is loosely defined as an imbalance. So what I mean by that is that we don't have specific reference ranges for the absolute or relative abundances of specific groups of microbes in the same way that we have reference ranges for LDL cholesterol. Mm-hmm. Now, if you buy a direct-to-consumer stool microbiome analysis kit and they say, oh, you have too much, streptococcus, this strain of streptococcus, it's outside of normal ranges. That company has actually developed their own reference ranges based on the healthy cohort that they chose to use. And the reason that's problematic is that healthy individuals, as you mentioned, their microbiomes are extremely individual. We have a lot of inter-individual or person-to-person variability. But we do see that microbiomes cluster in terms of similarity by geographic location to a large extent. So if your healthy microbiome is compared to the healthy microbiome of a person in another country, they might label you as dysbiotic, even though you are just another version of healthy. Yeah. So that's one thing that can make it really difficult too, to determine, the extent and the direction of changes. Like, is this a problematic change? Is this dysbiosis potentially harmful, or is this simply this person's best possible set of microbes given that they have a disease? And when we look at microbiomes, from disease to disease, there are signatures that are shared between diseases, which can also make it really difficult to determine, like, did this microbe play a role in this disease process? And if so, how did it also play a role in this other completely unrelated disease process? Or are we seeing sort of, like correlations that we are inaccurately applying causation to. And I think that that's the case, in many ways. So when we're talking about whether something is going to ruin the gut microbiome, it's difficult to determine, what it means to be ruined. But in most cases, we're looking at changes in diversity. So that's the both the variety of different organisms and their relative proportions to one another. And we do have evidence that there are some microbes that are associated with health benefits. So they might produce like short chain fatty acids or something that are helpful to the host. Mm-hmm. And then there are some that do have the potential to cause disease, like C. diff. I mean, C. diff is a normal resident of our gut microbiome, but it's not pathogenic unless the situation arises that it can start to really thrive. So there's a system of sort of checks and balances that involve the microbes themselves, of nutrient availability, environmental availability like real estate, and our own immune system that helps to kind of maintain the behavior of these microbes so that they don't cause disease. But there are certain situations in which those microbes are given the opportunity to grow, to thrive, and then produce virulence factors. So that could be something that we see happening after like long-term antibiotic use, so like chronic or
Which I
antibiotic
was just about to
overuse.
ask you about. So thank
Yes.
you.
Yes, yeah, exactly. So like you have a viral infection and you go to your doctor and say like I want to get some antibiotics. Those antibiotics are A, not going to effectively treat that infection, and B, could potentially contribute to antibiotic resistant microbes and have a negative effect on your microbiome. So when we need to really use those as directed. So that's one example. When people are following extremely low fiber or fiber devoid diets, or extreme, and that also happen to be extremely high in fat in many cases, we do
Certain
see.
population comes to mind.
Right. Yes, I know there are some diets people are probably thinking of, and I know that like maybe it's been associated with improvements in autoimmune disease, but there's zero evidence to support that. But there, in both humans and in rodents, this reproducible loss of diversity occurs, especially with bifidobacteria, which are associated with health benefits. They're actually considered. Many of those strains are probiotic. So that's another way that we can think about it. How, like, if we have a real loss of diversity and a loss of function of that microbiome, well, now it's not filling as many of the niches as it would normally. And keep in mind that we have co-evolved with this microbiome. And so it has played an integral role in human development, in ways that we might not understand entirely. But we really do rely on them for things like energy harvesting, so they can extract some more energy from our diets than we can. And they play an important role in immune defense. And there's emerging evidence that they may also play a role in cardiometabolic health, and perhaps even in cognition and brain function. So it probably behooves us, I would say, to like err on the side of providing our microbiomes with plenty of nutrients, and to avoid overuse of antibiotics if we don't need to use them. And then also things like drinking alcohol. That's another one that, beyond like very low intake, is associated with potential reductions in diversity. But it's very basic, like it's just kind of every day, like eat your fruits and veggies, get some physical activity, that kind of thing.
Definitely. I want to ask you kind of a follow-up question, kind of from our own curiosity. And you mentioned all these excellent benefits that the gut microbiome kind of provides with
Mm-hmm.
regards to cardiometabolic health, with regards to kind of energy harvesting, all those kinds of things. And in the hospital, oftentimes we see patients who are really sick and need a lot of antibiotics appropriately, because we're saving their life with these antibiotics likely. And then they're not getting good nutrition because in the hospital, either the patient is NPO because they're getting procedures, all of these kinds of things. And NPO stands for no perioral intake, by the way, for those who don't know. So it's just kind of this perfect storm of not feeding the biome. You have megadose antibiotics, you have no good nutrition, and then oftentimes after that, you don't really think about the biome. You think, oh, we saved this person's life. Would you think that these people need like very aggressive probiotic or prebiotic, all these kinds of supplements, or what is your take on that?
That's an interesting question. Because it's a really extreme scenario, and there's probably a greater likelihood that they have had significant disturbance to that ecosystem, and that when we take it to that extreme, and they are taking multiple forms of antibiotics that could work against a wide variety of microbes, that they haven't had adequate fiber maybe for days or weeks. And they're also in a hospital setting, and hospital settings are fairly notorious for acquiring hospital acquired infections like
Mm-hmm.
C. diff. Because there are some really virulent microbes that hang around.
Oh,
That
yeah.
so it's possible that those people are at greater risk, and in that case, certainly I would support if it's within their purview to increase their fruit, vegetable, whole grain and legume intake. Those are the sources of prebiotics. So prebiotics, so we use prebiotics as sort of an umbrella term, but it's actually a little bit more specific than that. So prebiotics are actually a specific form of microbe accessible carbohydrate that are used preferentially by microbes that we consider to be beneficial. But microbe accessible carbohydrates in general can be used by a whole variety of microbes. So these are carbohydrates that are resistant to our digestive enzymes. So they reach the large intestine mostly intact, and then they can be broken down and used for energy by those microbes. And those microbes can then potentially produce beneficial, what we call postbiotics. So like short chain fatty acids, like butyrate would be an example.
Mm-hmm.
But if we are trying to take just a probiotic, like we're just taking a bunch of probiotics, but we aren't providing adequate microbe accessible carbohydrates, then we are enriching this ecosystem with living organisms that need nutrients, and we're not providing them with nutrients. So one really interesting example of this comes from a study on bodybuilders. And they were intending to study probiotic supplementation in these bodybuilders. And they didn't really see any effects of probiotic supplementation, but they accidentally observed a really cool phenomenon that the bodybuilders who were following a fiber deficient diet didn't have the expected elevated diversity that we would see in an active population. Their microbiomes had the same level of diversity as the sedentary control group, whereas the bodybuilders who were eating adequate fiber did have higher diversity than both the other bodybuilders and the sedentary control group. So that does lend some evidence to the idea that even if we're doing things that are supportive of microbial diversity, like we're exercising regularly or we're taking a probiotic, we're not going to fully realize those benefits unless we are also providing those organisms with the nutrients that they need. And I think that is very logical, but some people still, want to just eat like a meat only diet. And certainly there are organisms that can use proteins for energy, that can use peptides. But the process of proteolytic fermentation can result in compounds that are associated with colorectal cancer, like P. cresol. So when we are providing our microbes with only protein and not enough microbe accessible carbohydrates, not only are we potentially impacting the diversity of the microbiome, we are also impacting the postbiotics, the things that they're going to be producing as a result of their energy production. So, when a person has gone through such a huge challenge, it certainly does make sense to potentially use like a high variety, high dose probiotic. But equally, they would need to provide, wide variety of foods. And they may not actually even need the probiotic, but there are some strains that could help protect against antibiotic-associated diarrhea. So that would actually be a case where you would have the evidence to support the application of probiotics for that reason. And you could also have the kind of collateral benefits of saying, like, maybe this will help to rebuild, with some beneficial strains, because they may have lost some of those, and those numbers may have gotten so low that it would be very difficult for them to bounce back.
Definitely. I like how you mentioned kind of buying probiotics, but also needing that fiber there to support them. And also taking this back to those at-home tests that you were mentioning a little bit earlier on. One of the problems that people encounter is sometimes they experience issues with their gut or perceived issues with their gut because they'll read online that their brain fog, quote unquote, or their diabetes, all of these things can be affected by their gut. Or they're just trying to act in a preventive manner and make sure that they're feeding their gut and not having problems with it. So if someone does have digestive issues, sometimes they like get a home test. It shows them this abnormal range. All of a sudden they start taking probiotics to bolster the other ones without prebiotics, all these kinds of things. So if someone is having gut issues or thinks their symptoms are related to their gut, what are the steps to take? Because you can't go to your family medicine physician who typically will not know very much about this. So you end up finding these online influencers that sell various things. So what should someone do if they have gut issues?
Yeah. Well, I do always recommend going to a gastroenterologist first, because they will be able to provide you with the valid clinical diagnostic procedures. They'll be able to rule out, whether there's, colorectal cancer, whether it's an inflammatory bowel disease, whether it's irritable bowel syndrome, because although a lot of people label IBS as a non-diagnosis, it actually is. There are specific criteria in place to diagnose IBS-C versus IBS-D or IBS-M. So we've got constipation, predominant, diarrhea, predominant or mixed. And from there, you'll be able to either know, okay, clean bill of health, there's nothing wrong with my gut, or B, I have some organic or functional disease and I can go about ways of treating that with, pharma or, dietary interventions, lifestyle, and things like that. And I think it's really important to stress that rates of colorectal cancer are actually going up in younger people. And so, although we think about it as like, oh, get your first colonoscopy when you're like 50,
Which is not 45, by the way.
right. Yes, exactly. Yeah. So we're responding now to seeing the change in trends. And so, just keeping that in mind that like, even if you're in your 30s, it's not something that is completely out of the question. And so if a person's experiencing, really chronic changes in their bowel habits, that's definitely a red flag. Like go to your doctor and get that checked out. And then I think what happens is that, when we have these maladies that don't have a clear etiology, like headache, brain fog, fatigue, influencers and marketers are able to really jump on that because we don't have a clear explanation for that. We don't have a clear understanding of the gut microbiome. And now you put these two poorly understood things together and say, oh, this is the root cause. You have dysbiosis or you have leaky gut, and that's what's causing your brain fog. And let me now sell you this supplement. Like I've told you that you have this problem so that you'll buy the solution from me. And what's often the case, what can often be the case, although, small intestinal bacterial overgrowth is a real condition, a lot of times when we're looking at people in like the diet industry, they are, they've been following like chronic diets for a very long period of time. So they're in like this chronic energy deficit, trying to exercise as much as possible, working, 45 hours a week, poor sleep hygiene, poor sleep, balancing, their job, their family, and their kids, and working out and whatever else. And so they are just legitimately tired. They're underfueled, they're underslept. And so they feel tired and brain foggy. And then people can say, well, here's this supplement that will help cure what's going on for you. And they're also encouraged to eat a lot of like fermentable carbohydrates. And so when I say prebiotic, those are fermentable carbohydrates. And those can lead to the production of gas, which can lead to bloating and some abdominal pain and flatulence. And it's a normal part of the process of microbes digesting, for lack of a better term, those foods. So it's a normal part of the digestive process. Now, it can become abnormal in terms of the extent of pain and discomfort, the amount of gas that's produced, things like that. But that, again, isn't necessarily there's something wrong with your gut microbiome or with your gut. It's just a matter of changing the amounts of those foods that you're eating so that you can comfortably digest them.
There's a lot. Oh, go ahead.
Oh, yeah. I was just going to say, so it's just kind of like, figuring out from a validated source what's really going on and then treating that appropriately with evidence-based scientific interventions, and not spending all of the money on invalid tests that are actually not telling you anything useful. Because like knowing, even if we did like have, like we don't have those reference ranges. So like, and we don't even have all of the microbes, all of their genetic data sequenced yet. So we don't have a full library of every microbe that's in your gut. So those tests aren't even actually showing you everything that's going on in your gut or what those microbes are actually doing. And so that information is not practically applicable. It's just information. It's just interesting. It's kind of cool to know, but you can't actually do anything with it at this point.
You've said so many good things, and I want to tie that to three things. The first one is your kind of the dichotomy between preventive and medicine. And I like how you say when people have problems with their gut, you should first make sure that nothing is wrong. Because let's say you're a 40-year-old male who has something going on. Okay, let's say you're 45. Let's put you right on the cusp. So you're a 45-year-old male, you've been having some trouble with your gut. And oftentimes, unfortunately, what people do for the first time is they see some new fad. They like go to their local health store, get a test or buy it online. They take some probiotics and hope that it goes away. But it could actually be a colorectal cancer or IBD. They could have Crohn's, all these different things, and they just don't know it. So definitely that would be the first thing to do, because those things can be life-threatening. And I've seen a lot of cases of those, unfortunately, where people just, it's a little too late. They go to the physician and next thing you know, they have a colostomy bag because they had to get a lot of their colon removed. So definitely that is the first step to take. And then the second idea I want to tie in is that if there is not a clear diagnosis, unfortunately, people do take advantage of kind of that ambiguity and the vagueness of kind of some of these symptoms that people have. And I was talking with my attending pulmonologist today, actually, and he was talking about how like chronic cough is one of those things where there are some diagnoses for it, but sometimes there's just a cough. People just cough for some reason. It's the same thing with our gut health. They have like this weird headaches and all of that. And people unfortunately sell things to try to remedy that problem, even though it's not evidence-based. It might not actually be a problem. It could go away on its own in the next couple of weeks, months, something like that. So it ties into that. And then the third thing it ties into is the other idea brought on by Dr. Carl Nadolsky, who was on this podcast earlier,
Yeah.
who said a lot of times when people have these symptoms, they're not looking at the basics, like what you were saying just now. They're not looking at their sleep. They're not looking at their general dietary pattern. Have they been eating the same thing, the same chicken and rice every single day without vegetables for like the past several months? So it's a lot of those basics, a lot of sleep hygiene, getting your varied diet, getting your exercise in, all those kinds of things. And then the last thing it ties into is just brought up is the information where, sure, we have this information, but what are we going to do with it? Is it helpful? Is it clinically correlate? Can we do anything with it? And oftentimes that answer is no. So I just kind of want to break that down, tie all of those things together, because that was a lot what you just said and was phenomenal.
That's great. Yeah, that was an exceptional summary.
So another thing I want to ask you, you mentioned going to the GI, and when a diagnosis is oftentimes vague, like it's not IBD, it's not one of the IBS subtypes, it's not colorectal cancer, great. But now what do you do? Who do you go to for gut advice? Is it physicians, like another family medicine physician? Because sometimes you see physicians that are interested in gut health and read a bunch of studies and suddenly think they have an opinion on it. Do you go to online coaches, PhDs? How do you find someone that knows what they're talking about?
That one is really challenging. And I think it's because, in part, like this is a very new area of research. And so, like, when we're trying, so we have kind of two branches, right? We have the research branch. So we have the people who are in the, in academia or, research industry, and they're doing like the benchtop work, the RCTs, the observational studies. They're generating the hypotheses and testing them. And then that is eventually translated in a clinically meaningful way. And that's what the gastroenterologist is going to base their treatment options on, or that's what the registered dietitian might be basing their, MNT on. But the issue is that we have this other branch of medicine. We have this branch of alternative medicine that is quite often not rooted in the scientific method. And in the area of science of alternative medicine, it's vast. I mean, there are many different forms. But quite often what can happen is that a practitioner, any type of practitioner, might ascribe to certain principles, certain ways of practicing alternative medicine that are not evidence-based. And then they, in a very practical way, like the way that they translate this pseudoscience in a clinical setting is to sell those gut, comprehensive stool analyses tests, or they sell Dutch tests or hair mineral analysis, or detoxes, like these programs that are not evidence-based. So unfortunately, like the state of healthcare at the moment, and the fallibility of of just people makes it so that the qualifications that a person has, that's sort of like their ticket to get in, but whether or not they can stay in the evidence-based party is based on the way that they practice and what evidence they're using to inform their practice. So although I really do say like gastroenterologist, because when it comes to diagnosing and managing diseases, like that's where you need to go. That person is going to be the most evidence-based option that you have, although there might be some that still practice in an alternative medicine kind of way. And the same thing can be said for registered dietitians. I know quite a few RDs who are into the, functional medicine, like naturopathic medicine realm, and they're promoting interventions and tests that are not scientific, not clinically relevant, and could potentially be harmful because they're causing people to forego the actual valid tests and interventions. And then, of course, I know some really fantastic dietitians, a couple of whom, are specializing in either GI or like Dr. Hoffman, her research was on the gut microbiome. So they have both the research background and the training, as dietitians to be able to support people. And then there are not many of us on Instagram, but there are quite a few of us on Twitter who are, researchers in the field of the gut microbiome, and we can help people to determine like what is actually evidence-based. And, and we're trying to do the work of communicating the science with integrity to what it's actually showing us, not overhyping it, although that's really an issue. So I would say that what people can do to arm themselves against being taken advantage of would be to get familiar with some of like the red flag terms. Like if a person tells you that dysbiosis or leaky gut is the root cause of your disease, that is not a scientific statement. That's not evidence-based. If they're trying to sell you a 5R protocol that's essentially removing and replacing your microbes, that is not an evidence-based standpoint. If a person is trying to make you take probiotics and they can't explain exactly what their probiotic strain is intended to do for you, then that's also a red flag, because there's no kitchen sink probiotic. Or if a person is very dogmatically in favor of one dietary pattern or another, if a person's dogmatically vegan, although I am fully in support of a plant-centric diet, the evidence does not suggest that veganism is superior to a prudent omnivorous diet. So I think that those are kind of like my red flags, that if a person goes to a practitioner and this is what they're saying, then just kind of use caution, because they are pulling from areas of information that are not founded in science.
I'm going to take that little segment that you just talked about, those red flags, and that is going to be a clip. And I'll put that on Instagram, because I think that's incredibly valuable, because sometimes you can't find the appropriate practitioner, and you'll find someone and you don't know if it's evidence-based or not. You can't discern it because you don't know it yourself. But if you do hear one of these red flags, I think that's really valuable, because now you know, oh, this probably isn't based on evidence, so I'll look somewhere else. And then you can just keep searching until maybe someone actually does know what they're talking about, if they do have these problems and need help with them. So that'll definitely be a clip. I'm going to clip it. It'll be up. You'll see it. Speaking of the evidence, we've been talking a lot about we're at the beginning of this period of research on gut health. We've been talking about it since 2000 BC, and it's just now that we're starting to learn more about it. The people are already calling the gut like our second brain. They're talking about it as the key to mental health, the key to cardiometabolic health, all these kinds of things. What do you think about the future of gut health research? What do you think the potential is? Like, are we going to have massive interventions for our gut to cure these diseases?
I think where we're probably heading is based on kind of my recent experience. I'm still have one toe in the water of research, and I've been in the process of now we're in the data analysis phase, but I helped a faculty member out of Tennessee to design an RCT on resistance training and the gut microbiome. And we were able to use something called shallow metagenomic shotgun sequencing. And it is a less expensive way of sequencing or looking at observing and quantifying the genetic material of all the microbes that are available. And when we're able to make those really advanced technologies more affordable, that makes them more accessible, and it normalizes their use. So now, instead of just looking at bacteria, which is what we were doing for many years using 16S methods, now we can look at a wider variety of microbes. And we're also doing more analysis of the functional diversity. So we're actually looking at genes and gene expression and postbiotics. So I think we're going to start taking more of a functional look at the microbiome, like not just who's there, but what they're doing, and trying to determine who's doing what. And there are also changes, I think, coming in the way that they're analyzing the data and trying to determine if there are relationships. So borrowing from ecology, like Mendelian randomization, to determine does this microbe potentially have a causative relationship with this specific outcome. I think that the field really is going also to address the issue of ambiguous definitions. Like terminology is a real limitation. It's a shortcoming, because we don't have a definition of what is a healthy gut. We don't have a clear definition of dysbiosis and things like that, but they're often used or sort of misused. Similarly to when we're talking about the gut microbiome, but the study is only used a fecal sample. That's not really the gut microbiome. That's the fecal microbiome. And those two entities are significantly different. So I think like what needs to happen is, developing these consensus definitions, more standardized methodology, especially when it comes to things like probiotic research, and then using, and then making these more advanced technologies more affordable so that we can, determine who's there with like greater resolution. I think all of that has to happen before we can start thinking about translating and developing practical applications. And I think we probably have to get rid of our desire to draw causative relationships between the whole microbiome and any outcome, and start to look more specifically at certain microbes of interest. And that's becoming more possible again as we're able to analyze large populations, pick out some microbes of interest, put those into a mouse, see what happens, and then develop some intervention trials from there.
So it sounds like when people say we're at the like beginning of gut microbiome research, we literally are not talking about like curing diseases, that kind of beginning. We're at definitions beginnings where we don't even know what the hell is going on. We're talking
Yes,
about like basic definitions, figuring things out, and then maybe way down the road we can start talking about intervention and all those kinds of things. So
exactly.
if anyone talks about they're out there of curing certain diseases or whatnot with kind of biome interventions, then probably also a red flag. So don't listen to them.
Yes. Yes, that's exactly it. Like those comprehensive stool analyses tests, they're like, this is part of, the whole process of like, really figuring out what's going on with you. And I'm 99% sure that person's not going to be able to go down that list of microbes and say, this is the data on this microbe, and there's evidence to suggest it could play a role in the pathogenesis of this specific disease. Very sure that's not going to happen.
Yeah. Well, it sounds like your dog is getting ready to go for a walk. So I'm going to start wrapping this up because we're also close to an hour. A couple quick questions. When it comes to prevention, kind of wrapping it all up, if people are thinking about practicing preventive medicine related to their gut, whether that's keeping a healthy gut microbiome, whatever that means, since we don't even know, or whether it means practicing prevention and promoting the cardiometabolic health, all these different kinds of things, what should they be doing on a daily basis?
As I have mentioned a few times here, I think like the foundations of eating a plant-centric diet. So as much as is feasible for you, eating a variety of different fruits, vegetables, whole grains, nuts, and beans at the vast majority of your meals, that's one place to start. And also engaging in some level of physical activity. That we've seen that even if people who are meeting the World Health Organization recommendations of exercise, that they have higher levels of microbial diversity than people who are living a more sedentary lifestyle. So that's another thing to keep in mind. Like if you can start doing some form of aerobic exercise, that could also be potentially beneficial. Limiting your use of antibiotics, alcohol, and cigarettes. And if you would like to add some fermented foods to your diet, that's probably not going to hurt you. We don't have very strong evidence for most fermented foods, but fermented dairy is associated with improvements in cardiometabolic health. And then really just using probiotics on a case-by-case basis, because that's not a kitchen sink thing that you need to be taking. And you'd be better off, using your money to support your fruit and vegetable intake or your gym membership.
Sure. Thank you so much. I learned a ton on this podcast, and I'm sure our listeners back home did as well. You sell a couple courses, correct? And then you also have some kind of like webinars and stuff. Where can people find those?
Yeah. So they can check me out on Instagram. I'm Vitamin PhD, and on Facebook as well. And then on Twitter, I'm the Vitamin PhD. Not to be.
That's got to be irritating.
Yeah. I was kind of like, oh, it was taken. Yeah. So they can find me there. And yeah, I have the webinar series and the book and whatnot. So always happy to help.
And if you're listening, all of our links will be down below in the show notes. So if you're driving or whatnot, make sure to check that out afterwards because there's a lot of value also in all of our Instagram posts. I've continued to read those. I've learned a lot from those. Led to a lot of my questions today in my research. So definitely go check her out. Gabrielle, thank you so much for your time coming on here. I really appreciate it. I learned a lot about the gut, and I hope everyone else did too.
Awesome. Thank you so much.